The last thing I wanted to do when talking about rules of exponents are some more of these practice questions. So what if I have a combination of a lot of the rules put together? One question that I've gotten before when I teach algebra is, how do I know which one of these to apply or what order to use them in? And really, there is not really an order that you have to go in, because all of these rules are in the same order of operations, the exponent stage. And since really we're dealing with just a bunch of multiplication and division, they all kind of fall together and you can apply them in pretty much any order. The only time you have to really worry about order is when you're dealing with adding and subtracting, which none of these are in that order, if that makes any sort of sense. And obviously you want to do stuff within a parentheses first, as well, but basically you can kind of apply them in different orders, and you should again always get the same answer. So let's say we were looking at a question like this one, which is 2x squared to the third power x cubed to the fourth power. Well, basically I would want to look at each one of these components separately, because again, with the order of operations, I have something to an exponent and something to an exponent. So first I could simplify each of these separately. So 2x squared cubed, well, what should happen to that is that I should cube both of these things, because 2 cubed would mean 2 times 2 times 2, which is 8. And then I would have x squared cubed. And notice that this one, here I have an exponent to an exponent, and that would that, and so here's a quick quiz, would that multiply or would that add? And again, this is where, we got to know our rules really well, but if we have an exponent to another power, those are always multiplicative. So 2 times 3 would be 6, so I'd have x to the 6th power. Or again, if you were stuck, you could always just expand this. This would literally mean 2x squared with 3 of them. So you'd have 2x squared times 2x squared times 2x squared. Of course, that would make 8x to the 6th. And then with the secondary one, I have x cubed to the 4th. Again, those would multiply to be x to the 12th. And since those were both in parentheses, that of course means that these are also multiplied. Now I have x to the 6th and x to the 12th. Those would now add, because I have x to the something times x to something else. And same base, different exponents, multiply together, always is additive. And that 8 would not change, because that 8 is something separate entirely, right? That is something I know, x is something I don't know. So x is combined together, because those are all in common. They have a common base. Whereas this is a different base that's not going to combine with the x's. And say, for example, I was looking at a problem like this last one, x squared y to the negative 2 over xy squared to the minus 3. Again, there's a lot of different rules we could use. We could notice that there's a negative exponent over here and flip it. Or what I would probably do is I would simplify the inside first, because what I can see is that there's a lot of common things in there. And I would first maybe deal with that, and then I can worry about the outside exponent later. And technically you could go either way, but with parentheses, working on the inside first is smart. Though technically you could just apply the exterior law, which is that if I want to, I could flip them over and change this to a positive. But if I were to start with the inside, what I have is x squared divided by x. Well, by subtraction rule, that's 2 minus 1 is just x, and that would always be on top. Or I could just use cancellation, as well, which is the same exact rule, the subtractive rule of x divided by x to various powers. And with y negative 2 divided by y squared, again, I could use the subtraction rule. That would leave me with y to the negative 4th. And this would be one where you might be wondering, how do I know if it's on the top or the bottom? But again, if you pay really close attention to the rules, if I have a to the m divided by a to the n, that always results to a to the m minus n on top. It's not on the bottom of the fraction if I just directly use the subtractive rule. So what I would have is x to the first power and y to the minus 4 power, because negative 2 minus 2 is negative 4. And that would still all be to the negative 3rd power. I could then distribute the negative 3. Sorry, this isn't really the distributive power, but it's similar, where if I have two different things raised to the negative 3 power, I would apply the negative 3 to both of them. So this would be x to the minus 3, and minus 3 would multiply to minus 4, leaving me with y to the 12th. And since again, these will multiply, if you have a negative times a negative, that will become positive. And finally, since usually when we have a negative exponent, what we'd want to do is apply the reciprocal rule or flip it. Basically, that would leave me with y to the 12th divided by x to the 3rd. And we only flip the y, or we only flip the x, I mean, because that's the only one that's negative. The y is not to a negative exponent. That one will not flip because only the negative exponent indicates division, whereas positive does not indicate division. And basically, you only want to be careful to flip anything with a positive exponent. And anyways, there's a number of different ways you could have done that, but you should come up with the same answer no matter what, as long as you're applying the rules correctly and not, making a mistake with where stuff flips or how the exponent is being applied in any case.